In this video, I'd like to talk about the reflection identities for the sine and cosine function. And here we have a picture of the unit circle where the radius of the circle is 1. And what we want to do is consider some angle theta. We can call this right here theta. And again, since we're on the unit circle, we know the radius of this circle is simply 1. And at a point on the unit circle, we have the x and y value, but remember that the x value is the cosine of the angle, and the y value is the sine of the angle. Now, with the reflection identity, we want to consider what happens when we reflect this ray here over the x-axis and over the y-axis. And we can come up with relations between the cosine and sine of the negative angle and the positive angle. So let's start by reflecting this over the x-axis. Will look something like that. And this angle now will just be the opposite of this angle. This will be negative theta. Since remember that the angle is measured positively when we go in the counterclockwise direction, and negatively when we go in the clockwise direction. And we want to consider what the sine and cosine of this negative are in relation to just the normal sine and cosine. And at this point right here, notice that the x value, which is the cosine, is the same for both theta and negative theta. So we can say that the cosine of negative theta would be the x value here, and the sine of negative theta would be the y value here. And like I mentioned, the x values are the same for both of these. And so we can conclude that the cosine of theta is equal to, let me use a different color. This is equal to the cosine of negative theta. So if we put in, let's say, the cosine of 60 degrees, this is equal to the cosine of negative 60 degrees. And for the sine function, we consider the y values. And notice that the y value here and here, these are going to be opposites of each other. If this is y, then this is negative y. So we can write that the sine of theta, this positive y value, is equal to the opposite of the sine of negative theta, since they are in fact opposite y values. So if we look at the sine of 30 degrees, then this is equal to the opposite of the sine of negative 30 degrees. And these right here, these are two of the reflection identities. And these two identities are often called the even and the odd identities, since if we consider even and odd functions, when you plug the opposite value into a function and you get back the original function, it's an even function. This function, actually, when we graph it, is symmetric about the y-axis. That's true of all even functions. And for odd functions, when you plug in the opposite x value or theta value and you get back the opposite of the original function, then it's an odd function. And these functions, running out of space here, are symmetric about the origin. So it looks something like that. Let me clean that up a little bit. But it has a nice symmetry about it. So sometimes these are called reflection identities, and sometimes these are called even and odd identities or symmetric identities.